Welcome to Walkabout the Galaxy, the still topless astronomy podcast, where the science is universal, the opinions are personal, strange is normal, top is out, down is in, and charm is all about the data. We are Strange, Charm, and Down the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Be sure to follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram. Catch our videos on YouTube. We are at Walkabout the Galaxy. Top Quark Jim Cooney's long-awaited return is on hold due to circumstances he will explain on our next episode.
yes,
Right?
it's happening.
Our stumper today is listener submitted
Ooh,
by Bob Winokur, who asks, if you could place a webcam anywhere in the universe and have a live feed to your new 100-inch 8K TV, and he specified provided the specifications for the TV, where would you place that webcam? Anywhere in the universe.
Jeez, that is a real
Live
stumper.
feed.
how for as long?
Oh, man. Yeah, I don't know. I mean, obviously, I have a hard time thinking outside of the solar system.
Yeah, and I'm a little
But also outside of the solar system, I think I would normally go to another solar system because on the timescales of things on your TV,
Right.
you want to have pretty active dynamic systems. So that's going to be planetary things,
Right.
maybe Betelgeuse,
Yeah,
just so that when it does pop off,
yeah.
you're ready.
But you'll spend your whole life and probably nothing.
Yeah. And then you're going to be going to the bathroom when it actually happens.
Right. That's the thing.
Maybe because, this is relevant to maybe one of our topics later, but I am absolutely fascinated by the images that we get from solar observations of the surface of the sun.
Yeah.
And just the convection, and it's just looks like caramel popcorn, and that would be just a great giant TV wallpaper to have.
Very high res, close-up view of the sun.
It's so cool.
That is a good one.
But maybe also something would you say Saturn's rings?
I may say Saturn's rings.
Yeah.
Because
that would be really cool.
there's some, but it could get a little bit monotonous after a time.
Venus. The surface of Venus.
Oh, the surface of Venus.
Yeah, if
Yeah,
I
so
can
you
put
can
a
see it.
camera anywhere and we're not using
have it-
hardware limitations, I'm going to do something that's really
Somewhere
hard to
that-
do.
Hard to see otherwise.
Venus.
Can we illuminate something, or it's just a camera and we get?
Yeah,
what we
you
get?
have a ring light or something
Yeah.
with it.
You can bring
Okay,
a ring
then,
light and a tripod.
Then beneath the ice crust on Europa,
Oh.
just in case there might be a alien octopus or
Okay,
something.
so to not go into the rings again, I'm going to pick the northern auroral region of Jupiter.
Oh yeah.
That would be cool. And do you have a UV filter on your
I'm
telescope
going to
on your
have
camera
a very
then?
broad spectral.
Yeah. Nice.
I think that has to be the
sensing.
case.
Because the
on the
aurora there are more UV than visible,
Yeah.
right?
And I think our listeners submitted this may be disappointed with our answer since we all stuck in the solar system, but it's a good point.
Well, Jim isn't
Because
here.
If you put it out by a star or the center of a galaxy or something like that, that's cool. But the time scales
Yeah.
for even very dynamic regions there are kind of long.
Yeah, I was
Yeah.
trying to think of something that
Maybe
might
a black
have
hole accretion disk,
Yeah, that would be that's a quick time scale.
stuff that's hot.
Something like some of the Cepheid variables have year-ish periodicity, right?
Yeah.
So something like a nova or a Cepheid variable where there's more daily periodicity.
Right.
That would
Oh,
be super
yeah.
interesting.
Yeah. Okay. Well, today we'll talk about a peculiar seismic ringing of the Earth, a potential mini-moon, some historical astronomy,
What?
some black hole stuff, so many things.
Oh, my
But
goodness.
first, this episode of Walkabout the Galaxy is brought to you by Lava Worlds.
Ooh.
If you love playing The Floor is Lava, then make a lava world your
love
next
that
vacation
game.
destination. With spectacular views of a sun filling your sky as your new home races around it, choose what time of day you prefer to spend all your days, as your lava world comes with built-in synchronous rotation at no extra charge. Featuring not just lava floors, but lava ground, Lava worlds are guaranteed to keep you on your toes. Try the night side for lava rain and enjoy a chocolate lava cake on the lava world of your choice. You'll love it. Lava worlds, this is no game.
No game.
Wasn't there a TV show called The Floor is Lava? That's my guess.
There was a TV show called The Floor is
for
Lava.
what that phrase is from.
Oh, that's a good one. I'm going to guess that. I'm going to guess that too.
It's Dungeons and Dragons.
Oh, I like that.
Okay.
So,
Fun.
yeah, there you go. We have a lot of space news type stuff.
So much is happening.
There's a lot.
We should
It's
start
an
with the
active
Polariston, which we talked about in the last episode.
Yeah.
And their spacewalk.
Update. It launched.
It launched, and actually there was something we said that was a little bit misleading.
Oh, no.
What was it?
What was it?
Addie's like taking note. Episode 371, the first time we said something a little bit misleading.
Wow, we need
10
an
years
errata.
in. Yeah. We were talking about the altitude.
Which of the things did we say wrong?
We were talking about the altitude it was going to, which was the altitude at which the spacewalk occurred, but it actually went higher than that.
I talked about that.
Did we give? I thought we only mentioned how high it went at the spacewalk.
Spacewalk was like 700, but
Right.
the highest was like 1400.
Right.
Yeah.
Okay. If we said that, then this is the errata. This is the mistake.
No, now
It
we
was a
just have
mistake
no
to give
idea.
this errata.
Yeah.
Jeez.
Well, so I mean, but also I think that number is a little bit misleading because I didn't realize how elliptical the orbit is. It's a pretty elliptical orbit,
Right. Yeah.
actually.
Yeah.
So it was like 1400 at the peak, and I think it did 7 orbits like that,
Something
which
like that.
apparently is the highest altitude orbit that we've done
Yeah. Ever.
since ever.
Except for
Since ever.
Yeah, since ever, because
With
the
humans.
Apollos
With
went
humans.
further, but
They-
they
but-
weren't.
yeah.
They were off
Yeah,
to the
yeah,
moon.
yeah.
So like Gemini
11 was
would
the
have been the
previous
last record holder. Yeah.
Yeah.
Oh, that's fun.
Yeah. But then the spacewalk was like when they did it was around 700.
Right. Yeah.
But it was also a very elliptical orbit.
Okay.
That one was, I forget, it was more elliptical than I expected.
Yeah.
So,
But the spacewalk was successful.
yeah.
Yeah. So sort
In
of
that
a
it was
space.
done.
I would describe it as a space peak.
Yeah. I would,
Sort of like a
they
space-
just-
you could, I would call,
prairie
I mean,
dog
you could
maneuver.
call it an extravehicular activity.
Yes.
I would not call it a spacewalk
Got it.
because
They
they both
were-
popped
Okay.
out.
Yes.
I think he went a little further out than she did, maybe, but maybe I just didn't see all of the pictures of when she went out.
Did they only 2 of them?
Only 2 of them went out, although SpaceX is calling it an EVA for all of them because the whole vehicle was
was it?
depressurized, so they were all in suits
Yeah.
and they were all
I
in
would
the
feel
vacuum
kind
of
of
space.
ripped off if I were one of the other 2, and they're like
I
saying you
know.
did an EVA,
Yeah.
but you were just like sitting in your chair in a
Like strapped
spacesuit
in.
while your
Yeah.
spaceship happened to be.
It looked
vacuum.
really complicated to move around and do that thing because the hatch opened. There was like a hatch thing that opened in. They had to like climb up and out. There's not a lot of extra room in that vehicle. They're in these big bulky suits.
Yeah, wasn't originally designed for that kind of activity.
wasn't.
But hey, it's cool.
But it worked.
It-
and the
it worked.
spacesuits
Yeah.
worked.
One of the things that made me nervous, and I haven't gone back and looked this up because it was early in the morning when it was happening, and I keep forgetting to look it up, is like there was some comment about like a seal popping out or something, and they were instructed to just like, and trained to just pop it back in. And this was like on the hatch.
Oh.
And like, that just makes me really nervous because vacuum seals are very tricky.
Seals are things that are very important
Yeah.
when you're in a spaceship.
And I was like, I have questions, but I haven't answered any of those questions yet.
Yeah,
So.
but it all worked.
So far, and they're
props to
coming
them.
back tomorrow. Maybe I
Before
haven't
this
actually seen the
podcast
landing date or location announced.
Nice.
But around here.
It's around Florida.
Around Florida.
Probably before the next tropical storm hits us.
Okay. Well, that's great. That's good.
I like landing, but that would work only if it was like coming down, touching down on a giant lawn.
Yeah. Like an estate.
Right.
So like the Starliner touches down in
It
the
was
desert.
A deserting.
A deserting.
Yeah.
White sandsing.
Some of the
What's our other space news?
Okay, let me give you this one, which you were hearing about. This is an interesting story that's really not space news; it's Earth news. But it's
Earth is in space.
Earth is in space,
it's
Josh.
geophysical. It's planetary news.
Love it.
About a year ago, in fact, almost exactly a year ago, it's September of 2023. Seismometers around the world started noticing a particularly regular signal with a longer period than is typically seen, and it persisted. It was a 90-second oscillation.
Yeah.
And it persisted. They detected it for 9 days.
9 days.
9
Right?
days, which is way longer than so this was not an earthquake going on for 9 days or anything.
Wasn't a volcano.
Wasn't a volcano. It wasn't something caused by a single impulse, and then for 9 days the earth was ringing.
For 9 days, the earth rang.
Yes.
I don't know. That's a
Dungeons and
tagline to a
Dragons.
movie. Yeah.
Sounds like it
does,
the beginning of a D&D adaptation. So
Let's make it so.
they figured out from piecing together the data and sort of localizing where things were coming from that what happened is there was a land/ice slide into a fjord, Dixon Fjord, on the east coast of Greenland. And that fjord, so it's a channel filled with ocean that is very regular. So the width of it is very constant. The depth is very constant. The bottom of it is very smooth and circular because this was presumably carved by glacier flows a long time ago. And because of global warming, glaciers on the bank thinned and allowed 25 million cubic meters of land stuff, which is a mixture of rock and ice.
What is that in units that I comprehend? Big chunks? Big chunks?
Oh, there was something. I saw it converted into Olympic.
How many whales?
It was converted into Olympic swimming pools.
Sure. How many
I
Olympic
think it was
swimming pools?
100,000 Olympic swimming
That's
pools.
a lot of
Oh,
volume.
no. Really?
I don't know for sure. I have to double
That's a
check
lot of
that. That's what
volume.
I'm remembering.
I need that number, again,
Well, a
transferred into
cubic,
something else.
a cubic meter, a person is less than a cubic meter.
I don't feel like it some days.
And so there's 25 million of those
So much.
of stuff. That's a lot of stuff. Dropped into the fjord, created a tsunami, giant wave. And basically what was happening is this wave sloshed back and forth across the fjord for detectably 9 days. I mean, it was gradually damping, but
So
the
does
damping
the
was
signal,
slow.
does the damping,
The amplitude was down to, it was 7 feet amplitude very quickly.
okay.
And then a few days later, a boat went up there and didn't even notice it because it was down to a few inches
Oh, wow.
at that point. But it was still producing detectable seismic signatures because you have this huge volume of water sloshing back and forth at a very regular frequency because, and the reason I was emphasizing this constant width and regular shape of the thing is because it's like a tuning fork. So there's a particular frequency that thing wants to vibrate at, and that turns out to be 11 millihertz, or about a period of about 91 seconds.
Whoa.
And so if it were a very irregularly shaped thing, there would be a bunch of frequencies, and everything would get all mixed up, and then it just become all the different waves cancel each other out,
Yeah.
basically.
Yeah.
Or becomes white noise part of the background. But this is this clear note.
That's super
sort
cool.
of singing out across. So I thought that was fun.
And I think part of the deal
And
with this,
depressing
yeah,
also,
it's also
but part of the deal with this is
Yeah.
why did it take a year to figure that out? Part of it is because they developed this super high resolution model of the fjord and the geography of the region,
the topography
and
and
all of that,
modeled
and
it.
they had to model it with super high resolution and include a bunch of the different the waves and the fluid flow and all of that stuff. I think
to show that
that
is
was
the
what
frequency.
happened,
Yeah.
and that was a frequency. So they developed a really high resolution model.
Yeah.
It's super cool.
Yeah, so that's cool. Cool and sad / depressing.
There's a movie. Why is it depressing?
Because
Because
why
it-
it happened.
Oh.
Like the reason
Yeah,
why. Yeah.
these things will be happening more and
Yeah.
more. Going back further, a detective story
Even further
in time.
to Kepler.
Yes.
Yeah, this actually ties in really well with some stuff happening right now because the sun has been very active lately. We're in a solar maximum, and this solar maximum is actually higher than predicted and higher than it's been in several cycles.
Oh, nice.
So
Big solar max.
Big solar max
The
is
actual
happening.
solar max is next year or so. The
I think that might be right.
peak. So it's and recently we've had some kind of weak ones. Like I think
have.
the previous one was sort of a weaker than average solar cycle. In other words, the number of sunspots and the amount of extrasolar activity at solar max was like, it's like, okay, solar max, but kind of
Pretty
not so
weak
impressive.
max.
And there was just recently a big geomagnetic storm that hit the Earth and made a bunch of
So what did Kepler do?
things. So I'm talking about solar max, and one of the interesting things about solar max is that we see all these sunspots, and so its solar maximum actually refers to like sunspot activity, basically. Well, they're correlated, right? So it's the amount of activity output from the sun, but it's correlated with sunspot activity. And like sunspot activity is one of the oldest ways we can track the activity of the sun, because even back before telescopes, you could do like camera obscura or like pinpoint cameras, and you could find sunspots. Because like if you make a solar camera, like just a pinpoint camera now, where you make it like basically the sun shines a point onto the ground, you can see sunspots if you do it, if they're big enough and if you do it well. They have to be relatively big ones. They can't be the little tiny ones, but you can actually tell. So Kepler actually used a camera obscura for part of his observations, which is this sort of, you're just playing with light basically, instead of a telescope. In those cases, you're projecting the light into the back of a chamber, you see it, and you can sort of sketch then. So all of Kepler's stuff is sketches.
Sure.
So there's this new paper that just came out by some authors. And they were analyzing Kepler's sunspot drawings from 1607. And the reason this is interesting is like we just don't have a lot of data from very early the sun behavior. And this first telescopic solar cycle was solar cycle 13 is what it's called. And we have observations from that, starting to use telescopes. But there's these big questions about some of the solar cycles because there's just not a lot of data. And right around that time, I think it's 1640, 1645 to 1715 is when the Maunder minimum occurred. So there were basically like no sunspots for that whole time, and it got cold.
Right, the so-called Little Ice Age So there's paintings of people ice skating on canals in northern Europe that don't freeze now, but
Oh wow!
So they did this cool sort of historical astronomy study where they looked at his sunspot drawings and estimations of like where he was for the observations and where the sunspots would have been, and they find sunspot groups near the equator in his drawings, which means it's toward the end of a solar cycle. So when sunspots form at the beginning of a solar cycle, there's like this butterfly drawing.
Right.
And at the beginning of a solar cycle, they form at higher latitudes. And then as the
closer to the poles
of the sun,
And
then as the cycle moves on, they form more toward the equator.
Right.
And so Kepler's observations were more toward the equator. So he was probably seeing sunspots from solar cycle 14 rather than solar cycle 15. So they're sort of like placing the solar cycles in time.
I see.
And this helps us better know the periodicity and like where things were then when they hit solar minimum. And there's also, they do some comparison with carbon-14 dating from tree rings to help time some of these things. And they compare it because
so cool.
Because there's more carbon-14 made during solar. It's correlated with solar minimum and max because that correlates when magnetic activity is lowest, and it allows like the higher energy radiation to come in and change things. So let's see. The isotope of carbon-14 is produced in cosmic rays, but when the sun's magnetic field help protect the Earth, when it's a stronger cycle, we don't get as much of that. So more carbon-14 is corresponding to solar minimum.
Interesting.
Yeah, so we can use that as a proxy for old times when we don't have data. So there's all these cool historical things that they're using to sort of piece this together.
Yeah.
But also probably the downside is like, this is really great work, but like it's just what it is now. There's not going to be like follow-up observations.
Right.
Yeah.
But it's helping piece the puzzle together a little bit more.
And props to Kepler because he was not the observationalist. He was the theorist to Tycho's observations. So good for him for actually doing some valuable observational astronomy.
And writing it down.
Yeah, 400 years ago.
Yeah.
Well, speaking of stars doing sunspotty type stuff, I was kind of blown away by some other observations of a different star, not our star, but a star called R Doradus.
Say that fast. Ardoratus. I don't know.
Ardoratus.
Probably could turn it into something else if we said it enough times. And these are observations made by ALMA, which is the Atacama Large Millimeter Array or something like that.
Yeah.
Nailed it. So it's making observations at longer wavelengths, infrared. And this is a star that's 350 times bigger than the sun, but it's about the same mass as the sun, which means the sun is going to follow the same basically mass tells the story of a star. So they follow a certain evolution that's pretty much determined by how much mass they have. So this star, billions of years ago, would have looked very much like the sun. 5 billion years or so from now, the sun is going to look like R Doradus, meaning it's going to swell up.
It's going to look like your Doradus.
It's going to look like our Doradus.
Doradus.
Our combined Doradus.
Our collective Doradus.
It'll be a red giant.
Okay.
350 solar radii would put it about at the orbit of Mars.
Yep.
Okay.
Yeah.
Actually beyond the orbit of Mars, so somewhere in the asteroid belt. So that could be the fate for the sun, or actually for the planets, the inner planets as well. So it's big.
Yay.
It's 180 light years away, which is far, but it's big. And this telescope array has the capability to resolve. We've talked about the amazing photos that it takes of like protoplanetary disks around other stars. So this observations actually resolve, it's low res, but it resolves the surface of the star, and you can see giant blobs of hot stuff rising up. It's like a gigantic lava lamp. Shout out to our sponsor. So giant blobs bigger than the sun of hot material coming up to the surface of the red giant, cooling off as they dump their radiation out into space and then sinking back down again.
And
so we'll
doing it relatively quickly, too, because like I'm looking at the figure and...
What's the time separation between them?
It's like a couple days.
That's yeah. So we'll post these pictures, but it is very cool.
Or like a week, maybe a week or two.
I mean, it's kind of incredible. You can look at they
have a 1 month cycle.
A star in the sky, and we can now actually like see stuff on the surface of the star.
There is a video, so hopefully we can share it too.
Yeah.
Oh, okay. Well, yes, we'll do that.
So that's fun. Maybe our last sort of space newsy short science topic is about a mini moon.
Yeah, there's a very, very small asteroid that was just discovered that is in a arguably maybe orbit around the Earth-Moon system. Some people are saying that it is. Some people are saying that it's not.
It's one of these mini moons.
It's a mini moon.
So we're finding more and more of these. They're in, so dynamically, they're in these like quasi orbits around the Earth, where it's like they sort of orbit at the same place, but also kind of around our. It's an interesting. Like if you look at the dynamics, like I finally learned about it when I think I taught Origins last time, as I like actually looked at what the dynamics are of the orbits, and like it's a pretty interesting orbit. They're these like horseshoe orbits that like are sort of locked with us, but not.
They're strongly influenced by the sun, so they're kind of like not tightly bound necessarily.
But the Earth is like the dominant thing right now governing their orbit, which is why it's in orbit around us.
Yeah.
Yeah, but it's interesting because like Earth isn't going to capture it by any means.
It won't be here. It won't be with us forever.
It won't. No, and it won't be with us for long either. But it is close now, and it's kind of cool. It made me think of the Phobos and Deimos debate, the hot debate that, are they captured asteroids or are they from a giant impact on Mars? It's really hard to capture an asteroid. It's just dynamically improbable.
Especially for Mars, which is kind of a pipsqueak.
Yeah, that's true. Yeah,
it's easier for us to do it because we're bigger and we have the moon, which helps do some stuff.
That is true.
That moon does help do some stuff.
Well, I mean, recently we were talking about, was it Lucy that did the Earth, Moon, or Juice?
No,
It
was Juice.
that did a gravitational assist flyby of both the Moon and the Earth.
Yeah.
So the more bodies there are in a gravitational system, the more crazy stuff can happen.
Like horseshoe orbits.
And so, So this one of the interests, so this thing is about 10 meters across. And one of the interesting things I saw was that the origin of this could be a debris fragment from the Moon.
What?
Yes.
In other words, they sort of tracing its orbit back. Where did this thing come from? Is it from the main asteroid belt? Is it from one of these populations of objects? Can't say definitively, but it's potentially something that was knocked off.
A lot of people are saying it's something that was knocked off the Moon.
Would that mean that so in theory, if it did end up like orbiting Earth as an additional satellite, would that technically be capture then? Or would it be?
Oh, that's a good point. Not really captured. It depends on where it went after it was knocked off.
It went away from home and it had its like Rumspringa.
It's only going to be with us,
and then it comes back.
Gosh, that's a deep cut. It's only going to be with us for a couple of months, though, at the moment, right? I think
It's just visiting.
It's just visiting.
Yeah.
It's like a long lost relative that's just coming back to visit. When did it leave the Moon? Was this from like
long time ago?
Like, so that's doing dynamical tracking.
Yeah, I don't know.
Where
how
they
far
like
back.
propagate back orbits and your error bars get real big when you go too far back.
Right.
So like maybe it's sort of from this general area. So we said the Moon.
I don't know.
I want to know.
Well, you should ask.
Maybe is it from the
Tune
is it
into
from the
some
South Pole
astronomy
Aiken
podcast
Bacon
and find out the
Bacon?
answers to these
Is
questions.
it from the South Pole Bacon?
Yep, it's from the Bacon.
South Pole Aitken Basin.
I'm reading about evolution of
Bacon-asin?
words, and maybe the Aitken Basin will eventually be known as the South Pole Bacon.
Then you can have a bacon number, but it'll mean a different thing.
That's right.
I don't know what that means anyway. Bacon number?
Your bacon number, Kevin Bacon?
My bacon number is 2.
My bacon number is also 2, I think.
Well, that
But
makes
it's a
mine
stretch.
3 at least.
No.
No?
I don't know.
Degree separation? If you're 2, then I'm 3.
It's accredited member of a thing.
Oh, you mean
So I'm in a
like
movie
IMDb.
Some
with
sort of production.
Elijah Wood, and Elijah Wood was in a movie with Kevin Bacon.
Yeah.
My Kevin Bacon number would be 2.
Got it.
Yeah.
Well, I'm not in any movie, so 0?
Infinite.
Oh, infinite.
Right.
Oh my gosh.
So let me drop the trivia on you, and then we'll talk about an astrophysical topic.
Oh,
Is that all right?
yeah.
I got it.
This is based on one of our stories we were just talking about. This is a sort of glossary trivia.
Okay.
That's not the word I'm
I
looking
don't know what
for.
that means, but I'm excited.
What is the name for a sudden oscillation of the water in a lake, bay, estuary, or other confined body of water, for example, such as a fjord?
Is this a multiple choice?
It is multiple choice.
Few.
Here are your choices.
Fjord. Few.
Yeah. Here are your choices. And you're going to have 2 multiple choice things like this.
Okay.
Seiche, riprap, and by the way, all of these are real geophysical terms.
Okay.
Oh, so you didn't make up any of these?
I didn't make up any of these.
He's not that clever.
Seiche, I
He
resemble
is that
remark.
clever. He is.
Riprap, hoodoo, avulsion, and cuesta.
I feel like I've heard some of those, and now I'm trying to
You may
remember.
have.
Yeah.
And then since it's an astronomy show, your second one is more astronomical.
Okay.
Which
Different oscillation.
What is the astronomical term for the following? The closest approach of one celestial object to another as viewed from a third body. Your choices in alphabetical order are an apulse, culmination, Lagrangian point,
Poorly timed. Sorry.
quadrature, and syzygy. So one of those is the closest approach of one celestial object to another as viewed from a third body. And then your other geological choice will come back to you after we take a journey out into the realm that this is in honor of absent top quark Jim Cooney. We've had fun talking about discoveries from the gravitational wave detectors, which have sort of opened up a new realm of astronomy. And there are 3 operational detectors LIGO in the U.S., one that begins with a V.
Isn't it Virgo?
Virgo?
Virgo.
In Europe, I think. And then one that begins with a K.
Kagra.
Thank you. You guys are doing great.
Thanks.
I'm
Helping me out here.
I remembered Virgo.
in Japan. And so the combination of those three things kind of provides a planet-wide opportunity to see things. And so most of the gravitational wave observations that have been made so far, we've seen mergers of black holes. And again, just by me waving my hands around, technically I'm producing gravitational waves because I'm redistributing matter in the universe. And matter warps space-time. So when I move my matter, that's like rippling a rope.
I think
or a
we should
fabric.
write an inspirational / self-help book about redistributing matter in the universe. You just have to redistribute your matter
There
in the
you go.
universe.
Oh, I
Because
see.
you matter.
You can affect the universe.
You can affect the universe.
Right. So the ones that we've been able to detect are caused by black holes, and we've all seen neutron stars that spiral together. And when they do so,
big
there's
things.
a lot of mass that very quickly is changing where it is. They're here, and then they're here.
Yep.
And those two heres were in different locations, dear
Yep.
listeners. And it's a lot of mass, and that produces a little blip.
One might say here and then they're there.
And the tiny blip, I should have said that. The tiny blip that it produces in the shape of space is extremely tiny.
It's crazy.
An incredible feat of engineering, technology, and science that they've been able to
measure
detect
this.
those
Because
things.
it's like it gets to the earth and it's just this little
The fractional increase in like the length of a meter is so small.
It's very small.
Absurd. But we can detect that. What's
job,
new is the possibility to detect a gravitational wave produced by a single star in our own galaxy
just a regular star.
popping off as a supernova.
Oh.
So not a regular star.
It's an individual star going supernova.
Wow.
If it goes supernova and the remnant that it leaves is a black hole, then there's a big, massive disk of stuff, if I'm understanding how this works correctly, around that black hole following the supernova, which expands. And as it expands, it takes angular momentum away from the black hole.
Okay.
And angular momentum must be conserved in that closed system, so the black hole spins down. And that spin down produces a gravitational wave chirp.
Really? That's
Yes.
the part of it that produces a chirp.
Yes.
That's not how I expected
That's
that
not how I
to go.
expected it to go either.
Did you read it wrong?
I think I read it right.
Cool.
And so,
fun.
that spin down is, there's a frame dragging is a thing in general relativity, which I will not pretend to understand at any level, deep level. But so that spin down is a acceleration, and that acceleration launches a wave in space-time. So these,
Is it a jerk though? Like, is it an accelerating acceleration?
No.
I thought you were just saying it was a rude star.
Is it really rude?
So, we're restricted because this is a weaker signal. We can only see it in our galaxy. The black hole mergers that have been seen with these LVK telescopes, gravitational wave detectors so far have been, tens, hundreds of millions of light years away in other galaxies, and the events that we're seeing there are more rare. But supernovas are supposed to be occurring kind of annually or so in the Milky Way, and generally we frequently can't see them because they're on the wrong, we don't have a good line of sight. This gives us another way to see them. We haven't seen one yet, but they're hoping that maybe, if not every year, maybe every 2 or 3 years, they'll be able to see one of these things if it's producing a black hole. If it blows up and leaves a neutron star, the signal is weaker, and then they wouldn't be able to detect it.
Oh, interesting.
Yeah, I think the other thing about this story was that they had so we've sort of hypothesized that these chirps would exist for a while, but the sort of range over which they thought they would happen was pretty narrow. And there was a new study that said maybe it's a broader range of signals than we thought we could detect. So there's an even higher chance than we
Sort
thought.
of the tuning or the frequency, because we only can see our gravitational wave ears are tuned to a
They're very
particular
tuned,
pitch.
Yeah.
So, yeah.
Pretty cool.
So that'd
It's
be
super
exciting
fun
if we
to
see
like
that.
see all the different. I mean, we know it can do like the big things. So starting to get to smaller things and other interesting events.
Yeah. Okay.
Spin down chirp.
What is the Spindown chirp?
I like it.
What is the name for a sudden oscillation of water? So the thing that I described that happened in Greenland
Do the other one first.
produced a kind of a wave that was sloshing back and forth in this thing, a sudden sort of like impulse wave in a thing. Is that called A, seiche, B, a riprap, C, a hoodoo, D, an avulsion, or E, a cuesta?
How is seiche spelled?
Seiche.
Seiche is a strong contender. Yeah. And like anything that's like a geology-ish term, it's really anyone's guess on like
Well, right
where,
now it's your
where
guess.
the
Yeah.
But these
like,
are
the country
geology.
board-
These are all geology
Yeah.
I
terms.
know.
I'm gonna
yeah.
go rip rap just because I like it. I don't think
Just
it's
'cause it's
right,
fun.
but I'm gonna do it
Yeah,
anyway.
Riprap is a good guess. Wait, what was the third one?
Hoodoo.
It's not a hoodoo.
It's not a hoodoo.
What's the fourth one?
Okay, come on. Avulsion.
It's not a vulsion.
Seiche.
You're going to seiche, and you wanted to go with seiche.
Yeah, I did, but I went with rip rap just to be fun.
Riprap is fun. A riprap is a layer of large, durable rock fragments placed in an attempt to prevent erosion by water.
Oh,
A seiche, and the spelling, because you were onto something, is like seismic.
yeah.
Yes.
Oh, yeah.
It is a seiche.
It is?
It is a seiche.
Oh, yes.
A hoodoo is a bizarrely shaped column, pinnacle, or pillar of rock created by differential erosion.
I thought that was a geology thing. Yeah.
Yeah. I
An
knew that was
avulsion,
rock.
an avulsion is the sudden cutting off or separation of land by a flood or an abrupt change in a
I
stream
knew that was a
course.
fluvial thing, but I thought it was a flowy fluvial
I
thing.
thought avulsion
so.
might be the one that you would guess.
No, I think it's another term we use in something else too, but I can't remember what. It's like emulsion. I'm just kidding.
A cuesta is a hill or ridge with a gentle slope on one side and a steep slope on the other. Yeah. All right, your astronomy term. Closest approach of one celestial object to another is viewed from a third body. Your choices were, again, a pole. I'm not going to repeat these, Audrey.
I'm writing them down.
Can I just answer?
Sure.
Syzygy.
I'll guess that one.
No.
What?
I didn't really. That was a joke.
It's
Too
not
late.
syzygy?
It's not syzygy. A syzygy is the straight line configuration of three objects.
Yeah, but okay. All right. I'll try again.
You'll try again? Okay, I'll give you the others. And you
Great.
Can, yeah. Your other choices are appulse, culmination, Lagrangian point, and quadrature.
It's not a Lagrangian point.
It's not Lagrangian. I think it's
I
the
don't think
second
it's
one you said.
quadrature.
Culmination.
I feel like I feel like
Either that
culmination
or-
because
yeah.
app is far,
Yeah.
para is close, and app is far. Culmination,
Your reasoning is excellent.
but it's app.
It is.
Oh, I hate you words.
It is an appulse, which is not a term I was familiar with. I also was not
Did
familiar
they just
with
say apples wrong one time?
with culmination, which is
You're not familiar with culmination?
not in this context. Man, I am getting a really hard time from the two of you today. There was some stuff before the show. Just going to say.
What is it? Appulse. How is it spelled?
Appulse.
I don't like it.
I mean, I was neutral
What is the
on
etymology?
it. I was neutral on it, but now I don't like it either
Good, thank you.
because your reasoning is sound, even though your manners are rude.
It's true. Oh, there's some pretty graph.
A culmination is the apparent movement across the local meridian. So that's
Oh.
like just the transit of the meridian.
Okay.
The Lagrangian point, we've talked about those before. Those are like JWST is at one of the Lagrangian points. That's a point in a two-body system where a third body orbits at the same rate as the second body
Yes.
in a stable
Yeah.
orbit.
Yes.
So like
Obviously.
the Trojan asteroids are at Lagrange points with Jupiter. They're orbiting the sun at the same rate as Jupiter. So they're in Lagrange points with Jupiter. Quadrature is when
Math.
things are sort of 90 degrees off. And a
Oh,
syzygy
gotcha.
is a straight line configuration of three bodies. So
okay.
for example, during a lunar or solar eclipse, the Earth, Moon, and the Sun are in a syzygy,
Fun. That's
which is a fun word because it has
Syzygy.
three Y's.
It's a very good scratch
Syzygy.
to also channel Jim Cooney, it would be a really good Scrabble word, but I think you can't make it in Scrabble.
You would need a blank.
You would need a blank.
Because I'm sure there's no more than 2 Ys.
Yeah. How many Z's are in syzygy?
Just one.
Just one.
Yep.
What is the etymology of appulse? I will figure this out before next time.
Okay, we'll post it or talk about it next time. While it may have felt like an avulsion, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to the Marsden State High School team and our listeners in Yugara and Guggengen country and around the world. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
And those are real places. We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.
Chirp, 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 chirp.